Okay. So have you done part A?
No.
Okay. So let me just draw it real fast. So what did you do?
I summed the
here?
forces. So for mass, so first I drew a free body diagram. For mass 1, I have a normal, gravity, and tension.
Okay.
For mass 2, I just have tension and gravity. I have set, it's weird, but I've set positive for this way. This acceleration is positive, and going down is positive.
Okay. That's not weird. That's how I do it too.
Okay.
It makes it much simpler in the
Which
end.
means torque will be positive.
Yes. So I would also have this way be positive.
Mm-hmm.
Okay.
That means this way is going to be positive.
Mm-hmm. So going into the board. So this is opposite convention.
Yeah. So my summation of forces for mass 1, I have T1 is equal to M1 acceleration.
Okay.
And then I have normal is equal to negative, or I guess it'd be positive mg,
Okay.
right?
Yeah, it's equal to m1g. They'll cancel each other out.
Wait, no, like, that's where I'm confused.
Oh, ma minus mg. So what will the acceleration be going this way for mass 1?
Positive, negative, negative.
It'll actually be 0, right?
Wait, the normal force would be 0?
The normal force won't be 0, but the acceleration will be 0 because it's only moving in this direction, right?
Acceleration going up, right?
Yeah. And so you'll be able to sum the forces in y and say the normal force minus m1g equals 0. So that's why you can say this.
But it is negative mg.
Well, on this side of the equation, yeah. But then when you move it over, the normal force is equal
Right.
to m1g.
I guess I got confused for a second because we set down going positive.
Oh, are you talking about? Sorry, I'm on mass 1.
I am on mass 1 too. Does it not matter?
No, either way.
Because normal is opposite of mg.
So you can have different coordinate systems for either of these.
Okay, good. Okay, I'm good. I'm squared. I
But
gotcha.
also, because there's no friction here, this is a smooth surface.
Mhm.
This end up not mattering, so we can kind of ignore it. So don't worry if that kind of threw you off.
So T1 is equal to M1A.
Yep.
Okay. No friction, so we don't need the Y.
Okay.
And then I have 0 in the, for mass 2, I have 0 in the X direction.
Okay.
And then in the Y direction, I have tension 2 minus mass 2 gravity. So tension 2 is equal to mass 2 acceleration minus, or plus m times g.
So this is where this comes in. You're down positive. So if down is positive, you want to make m2g positive.
Okay.
Minus, so you m2g minus t2 is equal to m2a.
mg minus t2 is equal to ma.
Okay.
Okay, that changes things. So mg is equal to ma plus t2.
Mm-hmm. So how many unknowns do you have? Oh, I guess let's call this right now.
Acceleration 2. Acceleration 1. Well, we only know mass, and that's it.
So T1 is unknown, A1 is unknown, T2 is unknown, and A2 is unknown.
Mm-hmm.
So that means we have 4 unknowns with just 2 equations. So we need 2 more equations in order to solve it.
Okay.
So
Unless the tensions are the same.
that would be another equation. The tensions equal to each other, right?
Mm-hmm. Do they equal?
Well,
If it's a massless rope and a massless pulley, they're equal.
Yep. So these are an action-reaction pair. So T1 equals T2.
Mm-hmm.
So there's a third equation. Now it's one other place you can find another equation.
The accelerations would be the same.
Especially since we made the positives going in the same direction. So we can say just A1 equals A2.
That's nice.
So now we can just make this A and this T. We can solve for acceleration just like that.
So okay, so we have mg is equal to m1a plus m2a. Is that right?
Yes. M2G equals M1A plus M2A.
M2g, right, because that's M2g. Okay, so then we factor out an A plus M2, M2g. And so we're left with acceleration is equal to M1 plus M2 divided by M2.
Not quite. So what do we have? We had M2G equals M1A plus M2A. You factor it out, so you have M2G equals M1 plus M2 times A. So you have to divide by this.
All right.
And you can't get rid of the G.
Right.
So
Okay, that makes sense.
So that would be acceleration for just the 2 blocks without the massless string and a massless pulley.
Right. So the things I did wrong was understanding that this has a different axis than this does. That since we're not accelerating in the x, since there's no friction, we don't care about the acceleration in the y.
Nope. And even if there was, acceleration in y would still be 0. Right? Because this is just going to slide sideways. It's not going to lift up or sink down into the ground.
Right, so acceleration equals 0 on the y.